Good morning. Thank you, Tara, for that introduction, and thank you to you all for coming to this morning's presentation. My talk this morning is about design, and I was particularly interested in trying to say something that kind of might be interesting for you guys to hear. In particular, I'm interested in how design progresses and how innovation occurs. And I'll try to address two questions in my talk. What is good design, and what is the nature of innovation? And I find innovation a very interesting word, concept. It's a thing we're often asked to demonstrate when pitching for new projects, but I feel it's one of those words like sustainability that can be poorly defined and fluid in meaning. I'm never too sure what's expected when we're asked the question, and often feel concerned that perhaps expected to always be making spectacular and bold improvements across all that we touch upon. I'm particularly interested in the idea of technology's strong association with the quantum leap of technology, which seems verified and unusual, and whether this really reflects innovation and technological development in practice. I'm reminded of a presentation at the Institution of Structural Engineers by Ron Pachman of Pachman Lucas 6 or 7 years ago, in which he argued, agitated perhaps, for the next quantum leap in construction. In this presentation, I hope to set out a basis for understanding the true nature of innovation. Good design is an idea that's we all have a feeling for, but it's hard to pin down. The approach that I will present allows for an understanding of design that may shed new light on intrinsic values within design and their strengths and weaknesses. I will use structural engineering as the reference point in examining these questions. I should admit at the outset that one of my vices outside engineering is reading, in particular, popular science books, but also history, economics, and the like. So much of my ideas on design that I'll present today are a synthesis of ideas from a range of sources. The starting point for me as a structural engineer and designer is that over some time, and having read many of the popular science books to be found in the basement of Waterstones on Gower Street, I realised I'd encountered the subject of design in quite a different context to my day-to-day life as a design engineer. I believe the question of innovation and design are worth exploring and tell us all something about the world we live and work in. In an era dominated by energy calculations and planning restrictions, it's all too easy to think that structural engineering appears static as a discipline. I aim to show that innovation in structural engineering is alive and well. However, the ideas I will present on design and innovation can be applied to much of what we all do, whatever your role within the property and construction industry, or indeed in general life. So, in order to give the speech, this talk some context, I'll start with a few thoughts on structural engineering. It's useful to consider a brief history of structural engineering, as that sets the context of my thoughts on design. Structural engineering was the first engineering discipline to occupy the space between architecture and building, as the technical possibilities of the new materials of structural steel, reinforced concrete, and pre-stressed concrete increased the possibilities and complexities of structural design. So in the period of roughly 1890 to 1920, these new materials began to be widely used in new construction. Famous firsts of UK construction include the Selfridges and Liberty stores in London, both despite appearances large-scale steel frame construction, and the Liver building in Liverpool, which is reinforced concrete. Of course, the post-war years saw a boom in modern and often innovative construction techniques, with the late 60s and 70s notable for identifying and curing the shortcomings of this brave new world. In my mind as a practicing engineer, the modern era of structural engineering, design, and construction starts in the 1980s and continues to the present. Here, I'm thinking of the principal construction methods and design philosophy, rather than suggesting nothing at all has changed. However, these aspects do appear to be mature, and relatively static technologies, with perhaps the most recent innovations in the world of computerized design, be that complex geometry, powerful and more sophisticated analysis, BIM, or collaborative ways of working, or perhaps the transition to Eurocodes. So where is the innovation in structural design? I've come to think this question is best answered through considering the nature of design first, and this is where we come to my commuter reading. The notion of design in popular science that I encountered is embedded in a kind of general theory of evolution. In this sense, evolution is used in a semi-technical use rather than the softer idea of something that simply changes over time. And then this idea of general theory of evolution seems to have started its journey as an aside in Richard Dawkins' famous book, The Selfish Gene. Dawkins suggested towards the end of the book that evolution need not be confined to the world of genes, but might be a more generally applicable theory, and suggested a unit of cultural replication, which he dubbed the meme. This idea, or meme if you like, was picked up by a number of thinkers and writers. One of these was the philosopher of science, Daniel Dennett. Dennett set out the basis of a general evolutionary algorithm that contains three basic conditions. Variation, in such there's a continuing abundance of different elements within a population. Replication or hereditary, the elements have the capacity to create copies or replicas of themselves. And differential fitness, the number of copies of an element that are created in a given time varies depending on interactions between the features of that element and the features of the environment in which it persists. That's his definition of that, not mine. I see this as an abstract theory at this stage. However, later I will show how I see this linked to the real world. There are a few features of this idea that are worth covering. This simple set of statements leads inevitably towards design. That is, they lead towards entities that are better able to meet the demands of their environment than their counterparts. Perhaps it is worth then considering the meaning of design, by which I mean an object or entity that is suited or tailored to its purpose. In this model, design accumulates automatically. I think the consequence of this driver of design are actually quite radical. The system will tend towards peaks in the design environment or fitness landscape. The peaks are whatever is effective in being replicated, be that a creature, an idea, or a design. Of course, the fitness landscape is not static. It may change slowly or rapidly, just like real landscapes. For example, in biological evolution, Stephen Jay Gould proposed the idea of punctuated equilibrium, in which changes appear to happen in relatively short periods of time with relatively little change happening in between. If this has validity, then change may be triggered by external environmental changes, such as an ice age, rather than an internal property of the system. Designs within the fitness landscape must then adapt to suit their new environment, or die out, of course. There is an interesting concept of a good tricks of design, in which effective solutions can be refound simply because they work, so-called convergent evolution. In biology, the dolphin and the unrelated reptilian dinosaur, the ichthyosaur, are often quoted examples of this. I use a phrase just then which suggests that good design is found somehow out there waiting to be discovered. In some senses, this may be true, in the sense that given a starting point and a design challenge, there are only so many functional variations of that design that still work. One can imagine all designs exist pre-formed, conceptually waiting to be discovered. The evolutionary algorithm shown earlier effectively searches this design space for effective designs, hence the inevitability included in my title. In structural engineering, example will probably be the I-beam, the shape of which is inevitable given the geometric properties of shape and efficient use of material. For example, if we were to encounter an intelligent technological alien species, it is highly likely they will have discovered and be using this shape for their beams. But I'm probably ahead of myself here and at risk of going way off topic. In that sense, good design is inevitable. Given enough searching, the best solutions will be found. The next writer that moves these ideas into the everyday world rather than the abstract world of philosophy of science was, for me, Eric Brockheimer. In his critique of classical economics and review of emergent economic theory, The Origin of Wealth, he proposed an adaptation of Dennett's theory, general theory of evolution, as I have called it, to the world of business. Brockheimer suggested three overlapping evolutionary environments for the economy: physical technology, social technology, and business, in which businesses combine physical and social technologies to compete in the marketplace. Of course, successful businesses make money, survive, expand, and are replicated and imitated, whilst unsuccessful businesses die off. So in this system, structural engineering and construction of physical technologies competing, as we're all familiar with, for cost, efficiency, and market share. A good recent example of evolution in physical technology is the smartphone. Social technologies influence how people and companies organize themselves. And whilst this isn't the focus of this talk, we clearly see shifts in this over time. Recently, and obviously, with the increasing use and dependence on the internet and internet-based applications. This way of thinking offers new definitions on design. Successful designs are ones that are used again, replicated, and imitated. Unsuccessful designs are those that are tried once or twice, but never catch on. Successful designs may not be the best, ultimate best quality, but rather a combination of usefulness, environment, and opportunity. This explains why sometimes seemingly great ideas or products never catch on, and vice versa. Designs and ideas that are once groundbreaking become redundant as the fitness landscape shifts. The thread of inheritance, that the properties of each generation of object or design or idea is based on the previous generation with variations, explains, for example, the variation in construction practice from contractor. Sorry, it was illustrating previous generations, influencing current generations. And then there's actually a thing that struck me when I became a young engineer, and we always asked the question, well, what's best? A steel frame, concrete frame, what's the best solution? And it always intrigued me that if you go to Europe or America, people build differently. So I think this explains why from region to region and from contractor to contractor, from between countries, the skills in the combined physical, social, and business technologies are refined to suit their local environments, such as legislation, available materials, and skills. A consequence of inheritance and the fitness landscape is that small incremental changes are likely to be more successful than large changes, simply because large changes are most likely to make designs dysfunctional. That's not to say that large changes are not possible, just significantly unlikely compared to small changes. An interesting example of this was highlighted by a former colleague of ours, Andy Foster, when he presented to his team at the time his thoughts on the transition from the structural bolt with a length of plain shank to the fully threaded structural bolt, which is now commonplace. And I promise you that as structural engineers, we really do mostly find this kind of stuff interesting. Well, at least perhaps I do. And I was fascinated by this, and he compared in his presentation, and if the guys who remember Andy Foster, who now works as an architect in Chester, he is quite an intense guy, and he really kind of studied this in some detail. And he compared the shift to the emergence of the flush-headed rivet in aircraft construction, which occurred as a series of improvements in the profile of the rivet until the flush profile was eventually achieved. So if you looked at the start and end point, you would see quite a radical change. But if you looked at each step along the way, you see a series of small shifts that take you to the end point. So therefore, it follows that much of innovation involves small steps of change, searching for peaks in the fitness landscape. In this respect, we should be encouraged to simply by striving to optimize solutions, adopting best practice, and making small improvements, we are participating in innovation. And of course, successful innovation is something that makes the businesses involved more successful, more profitable, and more imitated. Imitation really could be the sincerest form of flattery. And these are all real tribute bands. I think Bon Jovi-ish is my favourite, but there are good ones there. This challenges the quantum leap view of innovation. In fact, it seems to me that innovation is rarely truly the result of a bolt from the blue, and much of the claimed innovation is at risk of severe overstatement. Instead, innovation is the creep of change which eventually reveals itself. It's interesting to consider, say, the iPhone and how unique or otherwise it was on its first release, say, compared to other similar products on the market. It is a massively successful design, and it's also constantly evolving to outpace its competition. But we can see from contemporary phones that it wasn't necessarily unique in the marketplace at the time, but it was the one product that was emulated and was particularly successful. Perhaps the successful element is not the iPhone itself, but the idea of a sleek touchscreen smartphone with the ease of downloading and playing various programs or apps, as we now call them, and the functionality to connect across a variety of connection platforms. The touchscreen smartphone concept, or meme if you like, is the real success here. And of course, it doesn't guarantee, for example, Apple's survival as the market continues to develop and shift. This approach also challenges our notions of good design. Good design is in this way of thinking, is about usefulness, a usefulness that leads to a design becoming commonplace or ubiquitous. We chose a sourceman for this idea of design ubiquity because our graphic designer who put the presentations to the GIL found that after trying all the latest gadgets for heating milk for coffee, she had reverted to the saucepan. And in building design, I wonder if, in this context, the approach to a practice like Foster & Partners is scalable and can be approximated by other practice, which in my view has led to a similar approach being widely adopted by others, rather than, for example, high-profile architect practices whose buildings are more stylized. Of course, this need have no bearing on which you prefer from an aesthetic point of view. On a project level, in the arena of structural engineering, good design is about moving to the peaks of the local fitness landscape or design environment, where the peaks represent successful design and construction techniques. For simple projects, the designer may get close to the peaks pretty quickly, roll out the standard, near-optimized design and retreat. Reinforced concrete and structural steel systems have achieved near ubiquity in major building construction. However, for more complex and demanding projects, this process is often about resolving complexity and in doing so, reducing risk. A simple solution that conforms to the most efficient design and construction solutions of the day will be a fitter solution in the Darwinian sense. It will be easy to price and easy to build. But sometimes it can be far from clear at the outset where this rationalised design lies. So one of the key skills in modern structural engineering comes in identifying and resolving complexity. In this sense, the core value of structural engineering is still to understand structures at the margins of technical understanding, where detailed technical knowledge and skills are needed to deliver the particular demands of each project. Perhaps this is similar to the situation when the field of structural engineering emerged, only that the boundaries of the technology have shifted dramatically. Complexity can come in the form of complex sites, demanding project setups, say to meet a critical milestone or technical criteria such as stringent vibration control, or the challenges of groundbreaking architecture. But also the routine aspects of these projects need to be optimised, brought close to the peaks in their individual fitness landscapes. This works best when we can ask, together with our clients, contractors and collaborators, the simple question, how can we do what we do better? So by continuing to push for improvements, we are searching for innovation together. So good design innovation is not confined to the spectacular, but is embedded in everything we do well. So where does this leave innovation in structural engineering? In this evolutionary environment, we could say that the fitness landscape or design environment for structural engineering and construction systems is relatively stable. Of course, from a commercial point of view, contractors and developers are looking for the edge in cost and delivery efficiency, the how can we do what we do better question. But from a structural point of view, there is a certain stability in construction types. So what could change the design environment for structural engineering? As I mentioned at the start, building services design has seen a massive shift towards design to regulated energy criteria. This could happen too with structures, with targeting and benchmarking of embodied CO2. However, whilst there's been recent significant development in this field, this is not immediately implementable. This type of regulation could potentially change the types of structures that are built in order to comply with low carbon requirements. BIM may deliver a change in the social technology of the construction as design, delivery and facilities management processes are captured and integrated. This is bound to change the way we work, but is less likely to change the structures we design and build. The current drive for off-site fabrication may provide a pivot point to change the landscape. So am I saying there's no invention within structural engineering? Absolutely not. It's just in a mature set of technologies, innovation can be hard to spot when you're looking for quantum leaps and fast evolution rather than incremental improvements. And the point of this slide was in these established ecosystems, it looks absolutely constant. Viewed from the perspective of general evolutionary theory, we should not expect innovation to be a series of large leaps in technology and ideas. Innovation is the creep or rush of change, but almost always in relatively small incremental steps. In a new technology, such as the smartphone, there are endless opportunities and improvements to discover, although it is incredible to see the rate of convergence to a more or less single solution type. In a mature technology, such as structural engineering and the related construction systems, just as for stable ecosystems, the rate of change or innovation or evolution appears to be slower. That is, there are fewer radical changes presented. Whilst construction systems fundamentals may be broadly consistent over the last couple of decades, there are shifts in approaches and improvements. So that with hindsight, it's clear we're not building exactly the same structures now as we did in the mid-80s. Actually, I would argue that the design content of the more complex of today's generations of buildings is such that those buildings would not have been designed and built just a couple of decades ago. Innovation is real and happening, but only if we continue to challenge ourselves to resolve our complex projects and always strive to make every aspect of our designs as good as possible. If we do, then innovation is embedded in everything we do. Thank you.
It was surprising to me because it was much more philosophical than what I would expect coming out of an engineer, much less, even an architect. I wouldn't expect normally would go into so much detail about intellectual ideas. I found it quite inspiring.
I love the lucidity of his speech, and whilst I wondered where he was going to begin with, I enjoyed it, and it's very good. Thank you. I'd love to hear more of him.
I really enjoyed it, actually. He's obviously a very well-informed, very interested and an interesting person with a lively mind, bringing all sorts of topics from other writers and thinkers. Very, very interesting. Very interesting. And for someone so young.
Yeah, I thought it was very interesting, actually. I'm an architect, so I think the idea of innovation is something which maybe we don't talk about enough in construction industry. I'm always interested because architects obviously, as a sort of part of the leaders of design teams, we sort of potentially change the criteria quite radically by suddenly deciding that kind of very refined, lightweight structures are not interesting anymore, and how sort of design theory, as opposed to trends, somehow can adversely affect the speed of development and change.
I thought the talk was really interesting, yes, and it was sort of going through my head that what innovation do contractors bring to it. And I think actually, it is going to be a lot of innovation brought in by contractors shortly, because we're just going more and more prefabricated. And when you look at the relative costs of how much a building, the structure of a building costs, but how much it costs to put it up, and the time scales involved. It's the time, if we can shorten the time scale by 20%, we save millions and millions and millions. So I think the more you look what's happening in China, with the way they're prefabricating virtually whole buildings, so they go together like Lego blocks, that sort of thing has to happen here. And it's got to be led by major contractors, I think.